This is the first lesson in Unit 2, and it's literally about finding a derivative, and we use a difference quotient. So, one of the things that you will have to be able to remember is that all derivatives, um, well, they should be able to. You should be able to use this quotient right here or the one on the left. Definitely both of them you'll see on, if you're given a function, f of x, you'll need to be able to use both of these, okay? I won't, one of the ways you can think about this is basically the change in y over the change in x. So this is a slope. This is a slope formula here. And this derivative function, this difference quotient, actually comes from this equation. It derives from that equation. So we're going to practice doing that here. You're going to need to be able to do that on a quiz eventually. So we will literally get a derivative here using this difference quotient. And as you can see, what we're doing on this left side here, it's the same equation, except there we're popping in x plus h instead of just x. And then here, it's just the function as is. So let's look at the function that we are given in the next one. We're given this function. So when I write that, I'm going to ensure that I use limit notation here, okay? And then on the top, just addressing x plus h here, I have negative x plus h squared minus 4 times the quantity of x plus h plus 1, plus 1. Making sure I do all my parentheses. And then I'm just going to write the function as is. Negative x, all of this is negative. So negative x squared minus 4x plus 1 over h. I'm going to simplify the limit as h goes to 0. And right here, I get a negative x squared minus 2x plus h, 2xh, minus h squared. Here I get a negative 4x. I get a negative 4h. Okay, and then I have a plus 1. And I'm going to do the opposite of everything here. So plus x squared plus 4x minus 1. And all of that is divided by h. And this is just the use of the difference quotient. So here I'm going to go cancel some things. So these x squareds cancel. My 1 and my negative 1 cancel each other out. My negative 4x and my positive 4x cancel each other out. And then I'm left with all these h terms here. So I'm going to rewrite the limits as h goes to 0. And if you notice, my limit notation goes all the way down. It's as organized as it can be here. So I have negative 2xh minus h squared minus 4h over h. Simplified, I get the limit as h goes to 0 of negative 2x minus h minus 4. Plug my number in, plug in 0, and I get that this limit equals negative 2x minus 4. And that is literally the derivative. This is the answer to that question there. So, f prime of x, that's how we say it, f prime of x, is an equation that can be evaluated to determine the slope of any tangent line drawn to the graph of f of x at any value of x. So what we're going to do here is we are going to plug in these x values into this equation here, and we're going to get a number. And this number, we're going to compute. Now, I'm going to make a little another chart here, and this is my point of tangency. It's point of tangency. And over here, we're going to get the slope at that point. I'm going to get the slope at that point and the slope at this point. So my point of tangency is -4. I'm going to find it on the graph, and it is 1. Right here, -2, find it on the graph, and that point is 5. Right here, find it on the graph, it's -1, and that point is 4. Okay, and now I'm going to work on, and this is from the function f of x. This is f of x. These are points on f of x. These points of tangency. Now, the slopes of the lines that are tangent, we're going to calculate with the derivative. So, -2 times -4 minus 4 is 8 minus 4. And it just equals 4. My slope here is 4. So I go up 4, right 1. Let's say I wanted to do that here, up 4, right 1. I could create a little tangent line here. So I'm going to create a little tangent line. And this is for at 4, right here. Okay, so just some ideas around that. All right, remember next I have f prime of -2 equals -2 times -2 minus 4, or -8, or no, 0, 0. The slope here is 0. That means it's going to be a horizontal line at this particular point. And here's my horizontal tangent. Pretty easy right there. Here I have f prime of -1, and I get -2 times -1 minus 4, or 2 minus 4 equals -2. So that slope is down to right 1 at that point. So down to right 1, and it would be like some little tangent line going like this. All right. So pretty straightforward stuff there. Let's look at definition of a derivative. So once again, this is the equation. So I want to get the equation of the tangent line, and I'm going to take it from the stuff I had from before. So I know that the slope at -2 was from that same graph, that same table. Slope at -1 from that same table. Let's go back to that table real quick. I already got this stuff here, -2, 5, and 0, 0, -1, 4, so 5 and 4, 0, -2. So, point tangency is -2, 5, and -1 and 4, and my numbers there we had were 0 and -2. So my slopes, 0 and -2. With this information, I can easily write an equation using point slope form. So basically the same form. I already have a y, I already have an x. That's what this point of tangency is, and I already have a slope as well. So I'm going to find an equation using this information from the page before. And what I have is y minus 5 equals 0 times x minus 2, and I have y minus 5 equals 0, or y equals 5. This is point slope. This is the equation. Now, here I have, let's see, y minus 4 equals -2 times the quantity of x minus 1, and I get y minus 4 equals -2x minus 2. I'm going to add 4 to both sides. I get y equals -2x plus 2. And that's the equation in slope-intercept form. So not hard stuff. It takes like very little time. So now we're going to practice using the limit of the difference quotient to find the derivatives of the functions of f of x here. So I'm going to find these derivatives. So I'm going to be writing in the margin here. So I'm going to start here, the limit as h goes to 0 for this particular function, and I'm just going to do divide everything by h already. And here I have x plus h. I have positive 3. And then I subtract the whole function. 2/3 x minus 3. All right. And this equals the limit as h goes to 0, 2/3 times x plus 2/3 h plus 3 minus 2/3 x plus 3. And I'm going to go back and cancel. 3's cancel. This cancels. And I'm just left with that h on the bottom. I have the limits as h goes to 0 of 2/3 h over h. This cancels, right? And it's just 2/3. Like, I can't plug anything in. So pretty straightforward. And at the end, I would probably write f prime of x equals 2/3. So keeping that in mind, let's go ahead and look at number next here. And so this is the limits as h goes to 0. And I know I'm dividing by an h, right? So I have 1/2 x plus h, x squared, minus 2 times x plus h plus 3 minus 1/2 x squared minus 2x minus 3. And I'm just going to change that minus right here to a positive. And I'm going to change, yeah, so we're good. So remember, it's this function, the opposite of every term in the function. So simplifying, so I can make this look a little bit better. Look a little bit better because I can barely see it. So I'm going to go ahead and simplify this quadratic here. So I have 1/2 x squared plus, let's see, xh plus 1/2 h squared minus 2x minus 2h plus 3. I have minus 1/2 x squared plus 2x, and that's a minus 3. Okay, and I'm going to go ahead and divide by h. And if you notice, I am very keen on this limit notation. I'm going to go ahead and cancel some things. So this cancels, my 3's cancel, see 2x's cancel. All right, so let's simplify here. And I have xh plus 1/2 x h squared minus 2h over h. Simplify again, equals the limit as h goes to 0 of x plus 1/2 h minus 2. Throw that 0 in, and I get that this limit, this derivative, is actually equal to x plus, um, um, oh, sorry, x minus 2, x minus 2, and that's it. Um, More practice with radicals, you would just do um, the conjugate. You would just do the conjugate for that. So, um, so limit as h goes to 0, square root of x plus h plus 2 minus the square root of x plus 2 over h. So we do the conjugate. So we're going to do that. So we're going to multiply. I'm going to do the conjugate here. The square root of x plus h plus 2. And so the only thing that changes is right here. We put plus square root of x plus 2. So at the bottom, I need to write it again, plus square root of x plus 2. Right? And I made that distinction because people often forget to do it. It's a simple task. If you do it the right way, it comes out correctly, right? So this equals the limit of h goes to 0. So here, this just comes out of that radical. So I have x plus h plus 2. And then over here, these two groups just come out of the radical. And you notice I'm putting a little parentheses around that because that group comes out of the radical. And on the bottom, I have h, and I have all the parts of this conjugate, right? Right? So I'm not going to quite plug numbers in yet. You don't want to do that, okay? If I go look through here, I'm going to have an x and a negative x here. I'm going to have a 2 and a negative 2 when that simplifies. And what I have on top here, what I end up with is the limit as h goes to 0 of h over h times this conjugate, square root of x plus h plus 2 plus the square root of x plus 2. So I'm going to do is I'm going to cancel this out, right? It leaves me with a 1 on top, and I'm going to plug a 0 right here. And what I end up with is the limit as h goes to 0 of 1 over the square root of x plus 2 plus the square root of x plus 2. And when we add two groups, what we end up with is 1. When we add these two groups, we end up with 2 of these. That's all. We just combine them. We end up with 2 of these. And therefore, this particular limit equals that. So let's look at how we might find the equation of a line tangent to this graph. So first, I'm going to focus on my point of tangency. So I'm going to find f of 7. That equals the square root of 7 plus 2. That comes from the function x. So that point of tangency is 7, 9. Then I'm going to focus on my slope at 7. So I'm going to use derivative. I have it right here. Here's the derivative, guys. So f prime of x equals 1 over 2 square root of x plus 2, right? So I'm going to find f prime of 7 for that slope, and I get 1 over 2 square root of 9 equals 1 over 6. Now I have everything that's important here. I can use point slope here to find this tangent line equation, right? So y minus 9 equals 1/6 times x minus 7. And you could leave it like that. Like, it doesn't hurt you to leave it like this. If you want to solve it, put it in slope-intercept form, have a blast. But it's going to be a lot. I'll go ahead and do it for you. As you can see, that's 54 minus 47 over 6. Okay, but you can leave it in point slope form. So either one of these, unless they're like just specific about the form that's asked, you can typically leave it in point slope. Next, I need the derivative for this, but I can go ahead and get that point of tangency. It's just f of 1, which equals 3 over 1 plus 2, or just 1. So the point of tangency here is 1 comma 1. Now I'm going to go back up, get my derivative here. So the limit as h goes to 0 of 3 over x plus h plus 2 minus 3 over x plus 2 over h. So one of the first things I would do is bring all of that up. That's why we did problems like this in the previous unit. I don't know if you remember or not. And we're going to get these common denominators here. So I'm going to go ahead and do some little work so I can save some space here. So I would probably do x plus 2 over here on the top and bottom, and then times x plus h plus 2 on the top and bottom over here. So you can kind of see that. Now the denominators are common denominators. So I have 3 times quantity of x plus 2 minus 3 times quantity of x plus h plus 2 over, and at the bottom, don't forget about the h, the big H you're dividing by. So I'm going to bring that up and say h times x plus 2 times x plus h plus 2. I'm not going to simplify anything on the bottom yet, because that's a lot of work I don't want to have to deal with. So limit as h goes to 0, I have 3x plus 6 minus 3x minus 3h minus 6. I have h times x plus 2 times x plus h plus 2. Okay? Cancels, 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 and cancels. And guess what else cancels? While I'm at it, these h's here cancel, right? And I get equals the limit as h goes to 0 of negative 3 over x plus 2, this group, times x plus 0 plus 2. And you can see it's just 2x plus 2's, and it equals the limit. This limit equals negative 3 over x plus 2, and it's squared. So if you need to go back through and work with that, please do. But that is literally your derivative. Now that I have that derivative, I can go ahead and focus on finding that slope at 1. Okay, so f prime of 1 would be negative 3 over x plus 2, this group squared, or negative 3 over 1 plus 2 squared, which would be negative 3 over 9, and it simplifies to negative 1/3. So now I have the point of tangency, I have the slope, so I'm having y minus 1 equals x, no, equals 1/3, negative 1/3, negative 1/3 times x minus 1. If you want to simplify, you could say y negative 1/3 x plus 1/3 plus 3 over 3, which is just 1. And slope-intercept form says this equals y equals negative 1/3 x plus 4/3 for the tangent. Point slope form says it equals this. And that sums up that part. Next, we are going to get the equation of a derivative of f prime of x. So here you could do this using that difference quotient, which was the plan. But you don't really have to do like in fact I would rather that you do that and not necessarily worry about this here. Like we won't worry about this. So get the practice, find the limit. I'll tell you the answer here is negative 2x minus 4, but you should practice with the difference quotient. So if you don't remember what the difference quotient is, it's let's see, f of x plus h minus f of x over h. So this is good practice for the difference quotient. Right here, this would be 1 over 2 square root of x plus 2. Yeah. All right. Lastly, definition of the derivative: a function called the derivative that can be used to find the point of tangency, or the point of tangency. It can be used to find a tangent line. So let me erase that. It can be used to find the equation of the tangent line drawn to a function. The alternate form of that definition is that a derivative, a point that is the blank of the tangent line drawn to the graph of f of x at, yeah, a derivative that is the slope of the tangent line drawn to the graph at a point of tangency. I should have gotten a bigger block for that, but I didn't. But the classwork is pretty much the same. It's like using the difference quotient and then finding a point of tangency using the original function, finding the slope using the derivative, finding the equation of the tangent line using that slope gotten by the derivative and that point of tangency gotten by the function f of x. So have a great one. Hope that helps. All right, guys.